Welcome everyone to our webinar, SuDS, What We Can Learn from Beavers. Today we are joined by Adam Kane. Adam is Sustainability Lead at Aqua Water Management. He's also a civil engineer who holds a degree in renewable energy and energy management. He is passionate about sustainability, conservation and innovation. He founded a non-profit educational charity and campaigns for environmental change. At ACO, Adam leads the net zero carbon strategy and manages the development of carbon assessment tools. He also manages campaigns related to biodiversity loss and encourages conversation about the construction industry's impact on natural systems. The webinar today will focus on design principles of SuDS, the close relationship between principles of the beavers and the SuDS technology available. Adam will also be joined by his colleague today, David Smoker, Technical Director at ACO, and David will be on hand to answer any questions with Adam at the end. So any questions that you do have, pop them in the Q&A option at the bottom of your screen, and I will ask these on your behalf at the end of the presentation. Thank you for logging in today, and I'll now hand over to Adam.
Thank you, Derek, and thank you for that great introduction. Really fantastic. So hello, everyone, and thank you for attending today. It's greatly appreciated. So what can we learn from beavers? Today's going to be an interesting tale, with no pun intended, of the humble beaver and what as a species we can learn about the principles of SuDS. Moving on. Just a brief introduction to ACO and who we are. So we are a proprietary surface water manufacturer, delivering products to the construction industry. Obviously, we've got a vested interest in water itself and looking after it. We've also got a vested interest in looking after the environment. We've got different disciplines. So we serve the civil engineering community. We service the building drainage community in terms of internal inside buildings or high-rise buildings, and we also service the house and garden. So that's more of the your housing developments and things of that nature. But as an organisation, we've been on a sustainability journey. We've signed up to many different things in terms of we've got BES Responsible Sourcing Certification, to name one, which has recently been achieved with a very good rating. We've run a environmental management system for many years. We've signed up to science-based targets. We were an inaugural member for the Construct Zero program. That's construction industry's response to the net zero carbon emissions. And we've also about to sign up to the UN Global Compact as well and fill out the necessary paperwork for that. So it's not just about our commitments, it's also about our commitment to reducing. So over the last 7 years now, we've reduced our scope 1 and 2 carbon emissions by 68%, and we're aiming to be net zero by 2045. So we're trying to go as fast as we can in that downward curve in line with science-based targets and the various initiatives that I aforementioned. And if you want to learn any more about that, then please do contact me, because we've got a lot of presentation material about our decarbonisation journey and what it takes. So this is the agenda for today. We've got quite a few slides to get through, so I'll do the first section rather quickly. But first of all, we're going to look at the history of SuDS, where it originated from in terms of flooding and other things that happened in the UK. Then we'll look at some of the drivers, or the key drivers of what's brought us to the point of the necessity of having SuDS on all the various sites. Then we'll look at some of the principles in terms of holding water high up on the site and how we can mimic what the beaver is doing in principle. And then we'll look at the different design pillars of the SuDS manual, which is quantity, quality, amenity, and biodiversity. And they'll all make sense as I move through the presentation. So first of all, let's just focus on where SuDS came from. And it originated from the 2007 flooding, and it was the wettest summer on record was recorded. And this is data going all the way back to 1766 when records began, and there was an unbelievable 414 millimeters of rainfall was recorded across England and Wales, so just short of half a meter. And this caused 200 major floods globally, and it caused over £400 billion worth of damage. And this led to something called the Pit Review, and this was focused on flood risk management. And shortly after the pit review, there was the Flood and Water Management Act was released or was enforced. And then the latest guidance for the SuDS design, which was the non-statutory technical standards, was released in 2015. And there's been various changes across different countries, and most notably Schedule 3 in Wales, which is a mandatory requirement to have SuDS installed. And the EU also implemented directives to protect people from flooding. And to go with all of that, the industry responded as well with a sponsored document called the SuDS, Serious SuDS Manual, which was to guide engineers and people in the construction industry how to implement SuDS in the built environment and in the broader context of water management as well. Well, what's driven all this? Just to go through what were the drives behind the pit review and where did it come from? And I'll just take you through some of them very quickly because a lot of these are quite well known. So first of all, we know the population, both nationally and internationally, is growing. In a little over 200 years, we've gone from 1 billion people in 1804 to 7 billion people. And that's it's a growing trend in the UK as well, where there's been a huge increase in population. Urban areas are also becoming increasingly urban as well, and over 50%, 56% of global populations now live in city environments. But all this urbanisation and population growth is causing a growing detachment from nature, and it's having a dramatic impact on the planet. So to put this into context, in terms of the longer epochs, we've lost 46% of forest and tree cover over the last 13,000 years. In Europe, it used to be covered in 2/3 of forests, which has now dropped to less than 1/3. And in the UK, it's far more drastic. We went from having a 75% tree cover over 6,000 years ago, and that dropped to about 5 or just above 5% in 1906 or something around that region. And we've recovered back to 13%, but it's still a far cry from the 33% cover that you see in Europe. So we've got a lot of, we have to improve the way that we manage forests and we implement forestry across the UK. And in a stark thing happened in 2021, where man-made mass like concrete and steel, bricks, metal, and plastics now outweigh all of the biomass on the planet. And that really is scary stuff. That really shows you the impact we're having. And to further that impact, this is also having, our impact is having an effect on climate change. So there's quite a lot of, there's a lot of graphics on this screen, so I'll take you through one by one. So first of all, in the top left-hand corner, that is the temperature over the last 800,000 years. And it's also relating to carbon monoxide, And you can see 300,000 years ago was the next highest point, which was 300 parts per million. And in 2019, we were at 409 parts per million. Now, we can directly link this increase in carbon monoxide or carbon with the increase in temperature, which was the graphic you saw in the top right-hand side, which is being revealed. And then you've got the NASA data. You can't see where it's come from because of my scroll bar at the bottom, but NASA data in terms of the temperature increasing over time, or the average temperature increasing over time. I'd like to say one fact that really shocked me the other day. With our current trajectory of emissions, it will see over 2 billion people on the planet have a mean annual temperature of over 29 degrees by 2100 if we continue with the current trend. And that is very stark. 29 degrees is a big number. And if you're living in the UK today, then you can go outside and it's probably about that temperature right now, which is very uncomfortable. So Met Office data also shows that 10 of the hottest years have happened since 2002, but it's also getting wetter in the UK as well. And we've seen 6 of the 10 wettest years since 1998. Now, a fun fact for you, for every degree increase in temperature in the UK, there is a 7% increase in suspended water vapor, translating into more precipitation, which is rainfall, and is likely to increase by 1 to 2% for every degree of warming. And we already get quite a lot of rain, depending on when it falls in the year. Now, weather patterns are very interconnected, as you'll see from this video. And like throwing a stone into a lake, the ripples can be far, far reaching. So with El Nino happening, the temperatures increase in the Pacific Ocean. And what happens is typhoons, they accelerate because the water's a lot hotter. They deflect as they go up the coast, and then they hit the transatlantic jet stream. And that causes a ripple effect, which affects weather patterns all across the world. And it affects us in Europe. And you can see that rippling effect happening there. Now, to put this into context, I'm not sure if you'll be able to hear the sound.
What happened with Doris? Well,
hopefully you can, but this affects the weather patterns in Europe, which was explained by the Met Office presenter, but it creates something called a cyclonic effect, which causes a weather bomb. And I'll just play the videos and hopefully you'll be able to hear it, and I apologize if you can.
To look high up in the atmosphere towards the jet stream, a powerful jet digging down, and where we've got this little kink in the jet stream, well, that became an area where Doris really intensified. Running through the sequence, look at the satellite picture now, just look at that low pressure system really forming, and then as the storm approached the UK, the isobars just popping out of the center as Doris really continued to intensify, so that by midday on Thursday, the storm was down to 974 millibars, a drop of 30 millibars in 24 hours. That's what creates the number of isobars, and it's those tightly packed isobars that drive the strong and damaging winds that we've been seeing. So Storm Doris, a classic example of a weather bomb.
Thank you. So that was Storm Doris, and it was considered a weather bomb. So you can see some of the effects in the bottom of the screen as well in terms of the weather that we were actually seeing at that time of the year. But these weather patterns are becoming more and more common as we see more and more aggressive storms. But it's not just about we get increased deluges of water, if you like to say in that way, but we're also seeing areas of high water stress. And that means that water stress is where a water consumption outstrips the supply. And this is most common, or is the worst affected areas is the southeast of the country, and often why water measures are taken in terms of having meters on your house and things of that nature. But climate change is only going to exacerbate this issue further. And of course, we've seen, because we've got climate change, we've got urbanisation, we've got population growth, it's no surprise it's having a dramatic effect on biodiversity, and especially small mammals, invertebrates, all the things of that nature. Over the last 60 years, we've seen a 60% decrease in global biodiversity, and the source of that was How to Save Our Planet from David Attenborough. In the UK, we've seen declines across the board with key indicator species such as amphibians, but this could be connected to the lack of waterborne areas, with a 90% decline in lowland ponds in the 20th century. So it's really important that we bring water into our developments, into our lives, and make sure it's visible on the surface so it can be used by the natural systems. And of course, finally, there's our health. There's increasing demand for land, and this is placing a lot of pressure on green spaces. The Committee on Climate Change found that the total proportion of urban green space in England declined by 8% between 2001 and 2018. And now if we link this green space, or green and blue space, to our health, it would say £2.1 billion per year if everyone had access to good, high quality green space. So moving on, that was kind of the drivers behind where SuDS came from. And, you know, these aren't problems for now, they're continuing to happen, and we need to make sure that we're developing in the right way, and we're seeing water as a valuable resource it is, and utilizing it on sites or for whatever practices we're doing. So moving on, let's just understand SuDS a bit more, the practical principles of it and what happens. I know this is taking it right the way down to probably GCSE maths, but it's quite important nonetheless. So increasing urbanisation and impermeable surfaces where water can't penetrate means that there's increased runoff. So the water lands, normally it would infiltrate into the ground, and it would follow the ground strata and the groundwater table to watercourses. In the urban environment, it falls, it hits concrete, it hits tarmac, then it runs off quickly into the drainage system. Then from the drainage system, it either goes to the combined sewer. Then because the drainage system can't handle it, because it's clean water, then essentially they discharge dirty water through these controlled units that go straight into the watercourse. Now, the problem is that over a period of time with increased urbanisation, you don't get that poor water flow through the ground strata, and therefore the riverbeds and everything dry up through evaporation because the water just doesn't survive for a long period of time through the summer months. So having that infiltration to the ground is really important. So how can we achieve this in terms of how can we achieve the kind of introducing more SuDS into the urban environment? Now, first, let's say hello to the humble beaver, give him a good wave. Now, if there's an animal that epitomizes SuDS, this is it, and I'll explain why now. So first of all, they build a dam to keep the water upstream, holding it at its source, which is a key feature of quantity and holding the water on the site. The dam slows the velocity of the water and settles out particulates, purifying the water from things like nitrates and phosphates, which often quite come off farmland in certain environments. Now, this lowers the pollutant levels being passed further downstream, demonstrating the quality element of SuDS. This also creates amenity. They create amenity for themselves, using the dam as a home and also a place to harvest their food. So the increased water allows them to collect food from that surrounding environment. And the work they do has a massive knock-on effect on natural systems. Now, after beavers were released into a 2-hectare enclosure in West Devon, frog spawn increased from 10 clumps to 681 clumps. This attracted predators such as herons and egrets, while dragonflies, butterflies, aquatic plants, flowers, and also trees thrived in the new pools and new environments that are created by them. In Scotland, ecologists recently found that they increased the number of plant species by nearly 50% because they create such a rich variety of habitats, from saturated meadows all the way through to sunny pastures where moisture and light-loving plants can prosper, not in the shade of other larger trees and larger vegetation. Now, they're also being seen as a way of tackling flooding and are being released in record numbers across the UK, although this is still very limited and we need to have more input from MPs and from the government to make sure that more can be released in the future. But we have to find a balance between them being released and what impacts they might have on farming, agriculture, in terms of flooding of homes and things of that nature, because they will have a knock-on effect, be it positive and negative. So pictured here are the 4 pillars of the SuDS manual, and it gives you a bit more detail in terms of how we're managing the environment or managing the water. So this was released in October 2015. Now, these are the 4 pillars, which I mentioned about a few times now, are quantity, quality, amenity, and biodiversity. And just like the beaver, the core principle is that surface water should be managed for the maximum benefit now and in the future. So ideally, rainfall should be managed at the source and kept at the source as much as possible. And controlling the volume and the rates of runoff is the most effective way of managing the water for the maximum benefit. And we have to take every opportunity to make sure we reuse the water on the site. We infiltrate into the ground to allow for that poor water flow to the base of rivers. We have evaporation on the actual site itself that has a cooling effect. And we also use plants for evapotranspiration, so you have more of a cooling effect in the urban environment as well. London would be 5 degrees hotter if we didn't have all these trees. So it's really important that we make sure we integrate trees into the urban environment. Now I'm going to go through each section of the SuDS manual, or each section of SuDS, quantity, quality, amenity, and biodiversity, and break them down into how we design it in the built environment. So just looking at the design principles. So first we'll just look at quantity. Now the beaver builds a dam to deal with quantity, storing thousands of cubic meters of water. Now, how do we do the same, and what principles do we have to follow in order to do it? So there are 2 main ways of dealing with water quantity. This is attenuation or infiltration. Now, infiltration should always be considered first, and you assess the ground conditions and you see if this is possible, and you conduct infiltration tests to establish the infiltration rate. And that's a bit too detailed for this presentation, but that's the system you have to follow. And essentially what you do is you put the water either underground or let it infiltrate from the surface down into the ground, and it infiltrates into the soil itself. Now for attenuation, this is where you have such a poor infiltration rate that you want to make sure that you attenuate the water and then release it at a rate that the natural environment can handle, or the combined system, or whatever network you're attaching to. So the idea is the water, you collect it, you should really clean it, and then it will go into a geoscial storage tank or into some surface-based SuDS environment and then be carried forward into the system. In the example on the right-hand side, you can see that they've got high overflows, so you try and put it into the natural environment first, in a pond or a swale or a bioretention center, and then the overflow would then go down into an underground tank or into some other system. So it flows and it creates this kind of chain where you've got the storage happening at different and creating differing environments along the process. So infiltrate or attenuate. Now, for SuDS features like swales, there are different parameters when it comes to storing the volume of water. Generally, these can be designed for like a 1 in 30-year storm and have excessive flows carried over into the next SuDS feature. So always thinking about that linear pathway of water going downhill, and you creating these pockets of water resilience going down through. And then you want to design them so there's a maximum flow in them, the sides are battered back, whatever. But the idea is that you want to make sure that they've got enough, they have water in them either all the time, or that for biodiversity to thrive, where you've got a level of water at the base of them, or you have them where they've got the infiltrate into the ground, and again, they keep on supplying water to that base flow. Now, I just want to stop here and say, generally, on most sites in the UK or most developments, you'll design to something called the 1 in 100-year storm plus climate change. And that essentially is a storm that is, based on calculations, will happen once in 100 years. It's the easiest way of explaining it. And most sites will be designed to that parameter to make sure they've got resilience in the future. So we're trying to speed up because I'm very conscious of time already. So to deal with, to also deal with quantity, you can use like kind of storage on the roof. You can use roof spaces to store water, or you can reuse it through having taps, or using it for wash basins, or using it to wash your clothes and having that pipe work going back into the building and keeping a reservoir of water in a geoscial storage tank or some other medium. Water butts are also very popular as well, or rainwater harvesting technologies. But it doesn't just have to be one system or the other, as in terms of infiltrate or attenuate, so to speak. You can have a combination of the two to maximize the benefit for biodiversity on a site. So in these examples, you see that the water is being used and there's a high overflow from the system, represented just in this shot here. And the idea is you can line the bottom of the actual, any kind of technology you're using, so be it a pond or something of that nature, line it up until a certain level. Then you can have the overflowing volume infiltrating by the sides, and then you just end up with a pool of water at a constant level. Or you have an overflow where it can actually flow out the system if it's become excessive amounts of water are going into it. So that's just an example of different ways you can use it practically or maximize the use of water on a site. Now, we learned that the dam slows the velocity of water, so we're just going to look at the quality element. And now it settles out particulates and it purifies polluted water by removing nitrates and phosphates. Now, how do we do it in the physical sense if we're going to have to deal with pollution, say, coming off a highway? So for quality, the key driver is to remove as much pollution, pollutants before it's carried forward into a system, preventing it causing damage to any connected environment. Now, the SuDS manual splits the pollution down into metals, hydrocarbons, and total suspended solids, which is more to do with like silts and things of that nature. Now, what you can see here is a table they have, and you identify the pollution level based on the location of which your site is being implemented, and that will dictate how the pollution is removed. But first, we'll look at how the natural environment, or how we mimic the natural environment using green SuDS for pollution removal. And first of all, the thing is to consider that you need to have the water at the surface. And the core principle is to make sure that light can penetrate, or you have an engineered soil which can break down hydrocarbons, and light also breaks down hydrocarbons very effectively. So you want it as close to the surface as possible, where it can be, I think it's anaerobically digested as well, using engineered soils, and different gravel builds up is another way of doing it. And you want to make sure that you convey that water across the surface as much as possible. This isn't possible in urban environments. That's why essentially we as a manufacturer sell channel drainage systems, because it's safer. So you put it into a channel, you keep it at the surface as much as possible, preventing that localized flooding, preventing that endangerment of people being caught up in puddles and things of that nature, conveying that water at the high level, and then introducing it into a swale and starting the treatment train there. And like I said, the UV light and things like that will break down any kind of total suspended solid, the metals and the hydrocarbons in the actual the water itself as it conveys through. So, like as in each SuDS feature will break down the water or break down the pollutants in different ways. So in terms of just as a rule of thumb, we design our systems for a 1 in 1 year storm for the removal of pollutants, and that often is 65 millimeters an hour, just to get in the technical term. You don't want the water to be more than 100 millimeters in depth at that's within that storm, in that 1 in 1 year storm. And also you want to allow it to percolate down into the soil or infiltrate into the ground. So enabling that maximum penetration of light getting in there and actually breaking it down. Of course, just a few more technologies in terms of making sure, again, they're all referring to trying to keep it on the surface, trying to make sure they can be broken down, and it allows you to actually treat the water in different ways. But quite often it's all about making sure you've got that light penetration. And there's other technologies such as tree pits. They can, using different types of trees, can remove different types of pollutants. They can also act to basically essentially bring it up through their root system, and they can dispose of some of the pollutants themselves. So this is just showing how you can use GSA as storage systems to protect the root system, and then the water cascades in from the top and making sure that light can actually hit it as well. But these are very useful in urban environments in terms of making sure that you protect the tree, but also allow it so that you can break down all those contaminants. Now, when we end up in environments that are heavily polluted, there are a range of different proprietary systems you can use. So the idea is that they slow the velocity of the water, that settles out the total suspended solids, and then the other filter mediums can actually remove the heavy metals by chemical processes, and it can also remove those hydrocarbons as well through chemical processes. These are mainly put down to vortex-induced settlement, filtration, or sorption. And sorption is where there's a physical and chemical process where one substance becomes attracted to another in a filter medium. So those are kind of the different technologies. And what I always try and promote is that there's an equilibrium, or there's a flow between the two. So just to show you, there's different levels of treatment. So you've got low, medium, high. You can see how different technologies comparing to each other. But the idea is that you want to protect the natural environment and not rely on it to break down hydrocarbons, break down all those metals that are coming from tires. They're coming from man-made objects. They're not naturally occurring in the environment. They're us actually having an impact. So trying to remove it before it's carried forward is an essential part of what is required in any surface water management system to make sure that it's got longevity and resilience in the future. So you can see there, this is just a HEV park, and I'm showing some of the calculations required to actually manage that water, to manage that very heavily polluted water, using something called a quadriceptor before it's then transferred or released into a swale where it can be used by the natural environment before it's carried further forward into the system. And that's just showing some of the calculations, which we'll share the presentation after. It shows you the size of the system required for a given area of 500, is servicing 500 square meters of a heavily polluted HGV industrial park. Now just moving on. So beavers create amenity through the creation of their dam to sleep, essentially, where they live, and also store food for later in the season when it gets cold. They also use the extra flooded area to cultivate more food. So why and how can we use water to add amenity to our developments? So this is a quote from the SuDS manual. So good urban design aims to deliver attractive, pleasant and useful and above all livable urban environments. Now the key is to create tangible spaces. These are spaces where you can reuse water, where you have seating areas or where you have running routes, or less tangible spaces, which are things like visible living walls or green roofs where you can see them in the urban environment, but you can't touch them, but they give you a perception, a different perception of the urban environment itself, and that feeling of well-being and that you are still connected to nature. Now, we've got to use water as a resource, and using water as a resource, we should structure the urban environment, and it should be integrated into the very fabric of any new development, using rain gardens and bioretention centres for walking routes or next to the road to manage traffic, or creating recreational spaces with a pond for people to sit around on benches. This can be anything, anywhere, from industrial areas for a workforce, or can be shared spaces within a housing development, anywhere that the community can come together and engage in natural systems or green and blue infrastructure. And ideally linking it to human health as well, which from the driver's section we established is a really key indicator or key thing that we have to perform against in terms of increasing that blue and green space for our own health and well-being. And of course, all this green and blue space have a positive knock-on effect for habitats and act as a local resource for local environmental educational programs and working groups. And it's always recommended that these groups are engaged in the community while the development is starting or before the development is starting, because this enables them to have an impact and say what they want out of the development itself. And also you want to have good legibility, which can create a connection between the physical environment and the asset that's been built and lead people to look after it in the future. And I've missed an opportunity to talk about Habitat Matters here and trying to connect people between the physical environment, the physical environment, an additional asset that's been created to replicate it and submit biodiversity information. So trying to create a connection either by making sure people understand why the environment's been designed in the way that it is really important. We often walk amongst in our built environment and don't really understand why things are there. And making sure people, that environment has value added for amenity and biodiversity. And good legibility can create this connection. So signage, making sure there's visibility or allowing people to understand where walking routes are and follow them so they can engage in that environment. And SuDS or sustainable urban drainage systems can sit alongside that and really enhance that, that usability of a space. Oh, sorry. And that is Habitat Matters. And the idea is you can scan that QR code, you can understand why that pond's there, and then submit biodiversity information and really creating that legacy and providing that social value to projects which are really important in this day and age and should be focused on more. I'm going to skip that slide because it's just about recreation spaces. Now, the Beavers does a lot to increase biodiversity, from increasing that frog spawn to attracting predatory birds, and also all the insects and plants and tree numbers increasing. But how do we protect biodiversity and enhance it? Now, if the design is done correctly for quantity, quality, and amenity, biodiversity should just automatically fall into place. The design should help deliver local biodiversity objectives, whatever you're doing. And with a good design, a SuDS feature can provide adequate shelter, food, foraging, and breeding opportunities for a variety of wildlife species, including plants, amphibians, invertebrates, bats, birds, and also mammals as well. So it's key to make sure that you design the other three and make sure your plant is correct, which I'll go into in a minute. But SuDS schemes have to be where possibly have to link with each other. And this is quite heavily industrial for civils, but the road and urban environments are a major cause for disruption, should I say, but they create a divide between different environments, and that we need to bridge that divide and integrate them. And we have to make sure that we ensure there's the diversity of individual species and the genetic diversity within species is priority, and make sure the only way of doing that is making sure different habitats are connected. And we've shown this in terms of the tunnels you see on the screen to connect those different environments across the road and make sure that you can re-inhabit spaces that may otherwise have been decimated by pollution or other issues associated with destructive practices. And these are just some of the tunnels and actions, but it's not just those large tunnels for industrial things. It could also be the tunnel that goes underneath your garden fence. You're allowed hedgehogs and other small mammals to move and insects to move along, and just making sure you're creating those networks, those ecological networks, whatever environment you're dealing with. And making sure that it's not just about, you want to make sure you're mitigating the impacts of the built environment or any habitat you're dealing with, making sure that things don't get trapped. So gullies are a classic example of this. Invertebrates often fall in, small mammals fall in, and there's no means of escape. So having escape ladders and that ability to get out of that environment. So always consider those mitigating the impact of whatever you're doing to make sure that nature can escape and make sure it can thrive. Quite often what will happen is they get up to the outlet pipe and then they'll crawl down the pipe, and they're going into even further danger, and they're not actually escaping it. And of course, make sure wherever possible you create environments where you can have refuge for animals. And the key thing here is there can be natural refuges such as just big log piles, leaf piles, just making sure you created a space where nature can actually thrive. You can have things that are refuges that are bought off the shelf to enable that as well. Bird boxes, bat boxes is recommended by major architecture. I can't remember what it was, the Institute for Architectural and Engineering, I think it was, something of that nature. They recommended having a nest box and a bat box on every single property that was developed. And I think that's we can all take something like that, and it's really critical they're put in place. And of course, you have to have a diverse range of plants for animals to thrive in an environment. You have to create a variety of different landscapes, from permanently dry to wet to seasonal. And also you have to encourage that natural colonization of plants as well. We don't want a barren landscape when we build something, but making sure that it's the native species that come in to help nature thrive, making sure you've got the right colors and making sure that the plants you are selecting have got that biodiversity value. And finally on this, making sure you use water as a resource for biodiversity as well. And you should maximize shallow and occasionally inundated areas of emergent pond vegetation. And you should also enable that they've got those low-lying areas where you've got a lot of pollution resilience, and also have dedicated areas of water where you will not have any pollutants, which are connected to things like downpipes, where you're going to have a very low pollution level. And yeah, I think that concludes the presentation. Sorry, it was a quick fire. I think we're running out of time. So thank you very much for listening. Are there any questions?
Fantastic, thanks, Adam. It's just great to see how much that we can learn from the natural environment, and obviously how important these green spaces are to the urban areas. We do have a couple of questions, so and if anybody does have a question, just pop them in the Q&A option at the bottom of your screen. So are SuDS required as part of any new development? If not, what are the incentives to include it? E.g., can you link those water quality improvements to nutrient neutrality?
Wow. Okay. Shall I take that one, Adam?
Oh, easy. I don't mind. I don't mind.
Yeah. Right. Floods and Water Management Act 2010 had Schedule 3, which was, if it had been implemented, would have made it mandatory for SuDS to be designed and installed on all new developments above a certain size. It wasn't implemented, and what happened was that the planning process was used instead. But that, I think, to be fair, has been a bit patchy in terms of insisting that SuDS are on developments. There's some kickback from house builders in particular in terms of housing densities and that sort of thing. But the government has now indicated that they will almost certainly be implementing Schedule 3. So going forward, based on the Welsh experience, because Wales implemented Schedule 3 4 years ago, we should see that it becomes mandatory, certainly on developments of 10 houses or more, that sort of thing. So yeah, then we can get to insisting that it meets the 4 pillars of SuDS.
And do you think that the kickback that you get from the builders is because of the cost, or do you think it's maybe the space that they need to then have? Where does that come from?
Well, I think it's primarily the space constraint, because what seems to happen is they take a plot. So this is not tarring all builders with the same brush, by the way. Developers, they've got a plot size. They put as many houses on as they can reasonably for the price point that they're going for, and then planning come and say, oh, you've got to have sustainable drainage, and that takes away space which they wanted to put houses on. That means that the density goes down, so the price goes up. Some builders are actually very good, and the developers are very good, and they've actually got their heads around the benefits in terms of for the residents in terms of amenity, particularly in the biodiversity, the health and well-being aspects. And if properly designed, there's an indication that SuDS will increase the value of an individual property which is connected to it.
Fantastic. Given the current future issues of the general water supply versus the demand, would there be options to use water collected in SuDS to supplement supply, or are there too many concerns around the water quality?
Can I take that one?
Yeah, go on. Yeah.
Really interesting fact. So we as a society, we use on average 150 litres of water per person per day. Now, we only drink about 3 litres of water. So there's 147 litres of water essentially that we're using for other things. It could be washing the dishes, should be flushing the toilet, it could be having a shower. But a lot of those processes don't actually need to have clean water from a reservoir. We can just reuse the water that's fallen on the site. So we won't take them from SuDS, but we'll design it into the SuDS where you'll have that level of resilience. So it might be in all new builds we need to have rainwater harvesting tanks or a mandatory requirement, so that water that's falling on the site is reused into the site, i.e. for using for the basins and things of that nature, and not drinking water, or irrigation, not using water for that. So it is essential. It will be something that needs to be designed in London. I'm not sure if it's number 1, 2, or 3, but water reuse is right up there. It's in the top 3 in terms of the way the hierarchy of when you design and how you design. So it is becoming more prevalent in London. I can imagine that will filter through to the rest of or different cities in the future.
And do you think there should be more ownership and responsibility on the water companies? There's a comment here that they've seen increased scrutiny in the last 12 to 18 months. But does it go far enough? Should there be more pressure for them to tackle the issues?
Ownership, yeah, sorry, David.
I go back before privatisation of the water industry, where not everything was perfect, but certainly water boards, as they were, worked for the common good in terms of supplying water, but also starting to get into the environmental side as well. Privatisation took all that away. It's a particular hobby horse of mine, but what it means is that the water companies now are there to make a profit, basically, and they are constrained in terms of what they can charge customers, because there's a push to keep water prices as low as possible. So, you know, all these things don't make for a good environment or good workspace for water companies to do things off their own back in terms of improving the environment, etc., etc. They can only do it when either they're forced into it by legislation, regulation, or whatever, or where there's cost benefit to them. So, should they take more ownership? Well, I think it's more of a society-wide thing, and it's because these the water companies sit there, the environment agencies sit there, local government sits there, and the silos don't interconnect to actually make it work holistically as it should be.
Okay. Thank you. So there's one here. You said that nitrates and phosphates settled above the beaver lodges, but they are solutes and not precipitates. Sorry for pronouncing that wrong. How are they reduced by the storage? Is there evidence of this reduction?
Right. Okay. Chemically correct. They come in as in solution, but the two methods for nitrate, it's vegetation picking up nitrates to help grow, and they do need nitrates to grow. And there's also reduction of nitrate to ammonia, either by bacteria or by sunlight, and some absorption onto suspended solids. And phosphate is more or less the same sort of processes. And because the water is kept stationary for a longer period of time, it means that the total suspended solids can settle out more. So your suspended solids on the outside of the dam is lower.
Fantastic. And we've got one more question here. Do tree species vary in their ability to trap and absorb water-borne pollutants? Is there a risk of toxic contaminants killing off trees or planted vegetation?
It's a tough science. There are some studies out there that would say the different pollutants that trees can absorb and take for their root system and up through the tree branches. But obviously there's many different, or thousands of different types of tree, so not all of them have been studied. I know that the Tree Action Group have done some work on this, and it's worth looking at their resources on their website. And Sue, I can't remember her name now, but hopefully she doesn't watch this, she could kill me. But the owner of that is very good, and they've got some very good guidance documents that can help people, especially around pollution, around what tree to select on a site. Tree Design Action Group.
Fantastic. Well, thanks, Adam, for the presentation, and thanks to you both for the Q&A session.
Welcome.
So I just want to say that's it from us today, attendees. Thank you for logging in, and I hope you found it beneficial and informative.